Hi, good afternoon, everyone. For the past 2 years, when I did a session at reInvent, it was always on a Friday. So I got to wish everybody, safe travels and thank you for coming. So very glad to be doing it this time on a Monday. So welcome to reInvent. Hope you guys have a great week. I would also like to welcome William. William is from Netflix. He'll be joining me on stage later on to talk a bit about how Netflix approaches SecOps on AWS. From my side, my name is Armando. I'm a security architect with AWS. And what that means is that I spend most of my time with customers, helping them build security operations on AWS and how to operate securely in the cloud and specifically on the AWS world. In the course of doing my work, probably the most common question I got is, what are the best practices for this or that or the other? And sometimes there is an expectation that when we talk about best practices, that you will, or that we provide a set list of silver bullets, that if you do these 1, 2, 3, 4, 5 things, click some buttons, magically everything is all right. It's not quite what best practices are, nor what we will be discussing today. We'll be talking through some patterns for success, and also William specifically will be talking about how Netflix approaches it. It is a 200 level talk, so meaning that there is an assumption that you have some basic, very basic knowledge of AWS, but we will be introducing quite a number of concepts, assuming that you never had any experience with it as well. But we expect to know that, what EC2 is, or to launch an instance, and so on. So let's start from the top. Part of the security role, there's always one, right? Part of, at the core of the security role is to, protect assets. To know what those assets are, typically you have this notion of boundary, saying all the things that come within this specific space, they are the things that fall within the scope of my job. Everything that is outside, could fall in a gray area or potentially a completely black area. So let's start our discussion by talking about a bit what the boundary means in the AWS world, right? When we talk about boundaries, we are trying to accomplish, potentially a number of things. It could be that we are trying to minimize the impact of something going wrong. And when I mean going wrong, doesn't necessarily mean hacking into something. It could be about, just an operational failure or something that doesn't behave as expected, or a bug that triggers some kind of event that requires a reaction. Could be about segregation. You want to, separate different parts of your enterprise from the others to control risks in isolation for each one of them. Could be about data classification, a bit similar to the segregation side. But on the other side, we have this huge demand for things like flexibility, agility, innovation. So having a reasonable enough level of access to services that allows the enterprise to make the most out of cloud. The three most common patterns that we come across in this page are, particularly customers that are in the early days of moving to AWS, is the concept of building a data center in the cloud, which is one big, I'm going to say dumping ground, which is one single VPC where everything is going to move over. When you do that, it means that when we talk about segregation and separation containment of blast radius, you are primarily going to focus on a couple of things. The use of network level filtering using things like security groups or network access control lists. And from a platform perspective, and when I mention platform, I mean from the way in which you interact with AWS, you will be obviously using AWS Identity and Access Management, AWS IAM, but rely heavily on resource level constraints. So there's a lot you can do, but you can have slightly more elevated level of segregation than that, The next step that we see customers taking is really the one in which still using a single account, but in which they start creating multiple VPCs with specific functions. For example, it could be that one is for production, could be one is for test, and one is for management operations where Bastion hosts and other auxiliary services are kept. Compared to the previous, you now have access to a new level of controls to help you maintain and control how you segregate between all different types of assets and VPCs, namely through peering, so either you enable traffic between VPCs direct, yes or no, and routing in general, to the point in which they can be treated from a networking perspective as if it was purely an external party to your organization, although it may be, say, two different business units. From IAM side, it remains closer to what I was mentioning in the previous, so a lot of reliance on resource level constraints from IAM side. I think, and talking with a large number of customers over the past 3 years, very quickly we'll go into a position which you realize that actually the maximum level of segregation that you can have, and that it is quite flexible, it is at an account level. Essentially, it means that you are treating, let's say, two applications almost as they were two completely separate entities with no communication between them, be it IAM, be it network, unless you deliberately set it up. The way that customers approach this segregation at account level varies heavily, right? We've seen models like the one I have on screen, which is based on application or based on different teams, and different teams will maybe have different accounts for each application. In some cases, particularly with more larger enterprises, it could be that they want to take a model that is based on business units. Ultimately, it does matter a lot how you approach it, because you need to know where your boundaries are so that you know what kind of controls are accessible to you. But if I were to say two main things or two main recommendations that we'd say from an account setup perspective is to consider at least two of them. One of them is a way to aggregate all the data that is generated by all your accounts that is separate from the accounts themselves, so an account dedicated to that. And another one is an account that is dedicated just to your security operations team. Why have the two separate? Logging has huge value from a security perspective, but also has huge value from many other things: general operations, metric generation, performance, and etc. Having all that data aggregated in one single place, it means that you can easily publish the data and make it available to subscribers that need it, be them security or not. The bit about the SecOps is, and you will see this throughout, we'll talk a bit more in detail a bit later, is that it is key that the security teams also get the hands-on experience and the knowledge to operate on AWS, and that are able to also leverage our broad range of services to be better at doing security, so to speak. We will come back to that, but let's assume for a second that we have decided on our account model, right? We have a few accounts that are created based on a specific construct that is related to our enterprise, and we have some that are more related to operations on the security side. The second thing that we work a lot with customers on, and customers that are successful are really good at doing that, is when you have many accounts, it may mean that whatever set of security controls you identify, you need to be consistent in their deployment across all that multitude of accounts. And with that, we will jump quickly to something which is called, I assume most of you will be familiar or heard about it at least, which is CloudFormation, right? In the old, not the old days, even nowadays, sometimes when engaging with customers, we are provided with these large spreadsheets that have a list of controls, and we need to go through them and see which ones they tick. And the biggest step that we say in terms of becoming more agile, more effective in implementing those controls is actually to convert them to code, things like CloudFormation. Because meaning that once you have it as code, you can deploy those not just once in one of the accounts, but you can deploy it 1, 2, 3, 4 times across all the accounts that we just created in the previous model. Now, the question becomes about, I have a control set, I have a set of accounts, I want to deploy all this stuff in all my accounts. How do I go about doing that? We have a service that helps a lot with that, which is called AWS Organizations, which essentially allows you from, create hierarchies of accounts in which you control the level of access and what can be done in those accounts, and it can also be, of huge benefit to help ensuring consistency across what's deployed in each of those accounts. Let me show you an example pretty quick. Have we switched? We have now. So let's say that I am on my AWS account. I go to my organizations, which essentially will list all the accounts that I have in there. As you can see, I have a whole bunch of accounts. If I go to organize, these are all fairly structured for stuff that I use them for. But let's create a new one. Organizations. We will make for this 1, 2, 3. Makeup. We can give a describer to this account. Let's say prod1. And you get a mistake, which is that. And until not long ago, the process of creating an account means that you need to get a new credit card and essentially create a new account from scratch, go through a whole process that goes with that. With organizations, essentially you can do it programmatically. I'm doing with the CLI, but let me do a refresh here. But essentially, just with a quick call, you can have an account set up. The same way that I'm creating one account, and this is an activity that I do regularly, often for quite a few purposes. It could be that you need to create 10 in this case, or a 5,000 or so on. If we run this event called the Security Jam, in which we have hundreds of people taking part, and typically the way in which we provision those environments and ensure that they have all the same consistent setup, including in terms of controls to prevent abuse, it's exactly as I'm describing. Rather than using the command line, we would use code to launch those. Once I have that set up, I can organize my accounts in any way that I want. So create new organizational units and so on, and ascribe them some identifier that associates with what they do. In this case, what I'm going to do is simply run a chunk of code that will allow me to start deploying my control set, so to speak. To do that, the first step that I need to do is essentially to create a new role that empowers CloudFormation to execute things in this new account that I have. Let me go here, and I create a new one. Test, reinvent. And I'm going to move that to my tests at reinvent. And if I click there, it will give me an identifier. And essentially I have a few things, right? I'm just using one account, but let's assume that I created a structure with 5 or 6 or 7 or 5,000. What this allows me to do now is I can go back to my CloudFormation. So all that I'm trying to do is a deployment of consistent controls across a large number of accounts. And I can create stack set. And I can create my stack set. For this case, we will just enable AWS config. We go to next. My stack set. Where do we want to deploy? In this case, we are using organization. So you can simply, by referring to the organizational unit, just press play and deploy it wherever you want. We'll just go with all of them. And we go next and next. And create. Tick. That's a bit better. It will show down here as outdated fairly soon, but yeah. And it will start deploying. We are not going to wait on the completion, but essentially the process that we just went through is that. We created a number of accounts. We have a control set that is based on on a set of controls that we know to implement. And now we just need to deploy. There is a bit of, it sounds a bit like magic, taking control sets that typically could be hundreds or over 1,000 controls and converting that to code. We do provide quite a bit that should help you get started. We have this thing called our quick starts, in which you can go there and have a baseline set of controls to do with HIPAA, NIST, and PCI DSS, and also a UK one. So that is a good starting point. Now, we did that. The second one that I like to say is accounts, code, deployed. Once you have things as code, it means that you can, start doing tests with your structure that it was unlikely that you were able to do them in your old deployments in traditional data centers. Typically, when assuring or auditing or testing networks in traditional settings, the way that those tests are carried out would be either by sampling, looking at a small set of your infrastructure and see if it meets a baseline, or it could be very often just a case of launching a battery of test cases. Often, if it's vulnerability scanning, just doing large-scale fault injection and see what comes back. As we move to more of a code-based approach, we can actually do this more on a software-oriented basis, right? We can think of release stages for our infrastructure with standardized phases which could match the ones that I have on screen, or being something that is more specific to your organization. In this case, the one that I'd like to show you, which is something that I set up earlier, is a way to do it, or a potential way to approach it, is to use the code star. Well, code star now is a bit misleading these days, but code pipeline and associated services to be the pipeline that validates your code, and that validates your CloudFormation, and that baselines it against a common set of cases, right? Let me go to Ohio, and you will see what my pipeline looks like in there. If I can find it. There we go. Right, so I have one pipeline in there. The only purpose of this pipeline is each time I update the infrastructure, it will start processing it and run a battery of tests. It will be in a failed state for now, which is fine. But essentially what happens is, these are the stages of my pipeline, right? Commit, meaning I have a new release that I just made. As soon as I deposit that in S3, in a specific bucket that I have nominated, it will do the first level of checking, which is, it's likely better. So as soon as I put it in S3, the commit stage, it will pick it up, open that file, and start assessing. I defined a couple of things in there. The first one is a static code analysis phase. There are quite a few open source tools out there. One that comes to mind is CFNAG from Stelligent, and quite a few others. But essentially it's about doing that first health check to make sure that this CloudFormation is actually doing something that makes sense and that I can trust. Looking, for example, for something as simple as, am I creating security groups that allow SSH from the whole internet? Or am I receiving passwords as input, but I'm not obfuscating with asterisks the password, defining it as a password field? If it passes the first one, it goes into my test deployment. And what I do in there is have another account that is just dedicated to testing. And what it do is launch the actual CloudFormation in that separate account, and once again, run a battery of tests against it. The battery of tests, although I have it defined as Lambda, with customers, very often that will trigger is actually tools like vulnerability scanners, potentially even manual pen testing if you are so inclined. And in this case, I'm just doing continuous integration, meaning that if all those tests until now have passed, I will get a pop-up that says, hey, approve the release, and it gets translated into production. If it doesn't get, it will just say, sorry, you failed, like it is showing right now, and go back to the beginning. All the code examples that I'm showing you, I will share. So if you will take pictures, I will share at the end links that will get you the to deploy exactly what I'm showing you, so you'll get that. Now, one of my favorite topics is the way in which we build the controls themselves. The talk or the current talk on best practices for SecOps, it originated earlier this year. We did a webinar about it where we introduced the concept of control, monitor, and fix. And what we observed is that, having these three principles in mind for each time you implement a control can be quite effective. What I mean by that is, control essentially is a mechanism. It's the thing that drives a secure outcome, right? Or that drives compliance to something, but it is your intended goal. For any control that you implement, you should consider how to monitor it. Is it operating as it should? Has any anomaly came up? And if we identify a situation in which something is not operating as you expected it or as you desire it, take action to fix it. Ideally in an automated fashion. Particularly when we look at the fix side of things, there's a spectrum of options in there, which I group into three stages, right? We talked about the concept of a logging account at the beginning. So when you have a logging account and you are just aggregating data, but not doing much with it, you're primarily using it for look back. It could be for forensic purposes, for example. It could be also to generate MI, management information, right? General aggregated metrics that provide you some insight into your environment, but not necessarily driving correction or improvement. The next level above that is when we talk about enrichment and alerting. And enrichment and alerting is taking the raw data that we generate with things like, for example, CloudTrail, which is our journaling services for storing all the calls made to our APIs, and enriching with information that is specific to you. If you have a CloudTrail event that says, I don't know, someone launched an instance, probably most of the times you will ignore it. If someone launched an instance, but it is in your most sensitive account where you're not supposed to launch any more than what it is there for some reason, and the launcher actually is someone outside your organization, that is a bit more concerning. If it is an instance that happens to be launched in a region which that for some reason you are not expecting to operate at all, that starts to be very high signal, very low noise, right? So enrichment helps you in making the most out of the log data. And the last step is where the money is, right? Which is when you have automation that drives you either towards correction or towards stopping the issue if such action is warranted. Let's consider a few examples. The first one is the perennial example of automation on AWS, which is CloudTrail is one of our main logging services. If someone stops it, that is something that is high signal, low noise, that something that shouldn't be happening is actually happening this time. So we can detect that easily, right? We see that there's a call to stop trail, and the fix is actually quite obvious, right? We turn it back on. Obviously, we should also alert because it will need some kind of investigation. But end to end, from detection to spotting it to fixing it, we know what to do. Another example is, if you are only expecting SSH from a Bastion instance, and you see someone making API calls that change your security groups to allow sources from somewhere else, the fix is also quite obvious. You can get it done. Now, a slightly more interesting one is this one. So let's assume that you have a baseline set in which you want all your instances and the software inside them to be at a certain level, right? Patched up to so much. We released roughly a year ago a service called the Systems Manager that allows you to get a lot of visibility to what's happening in the instances. So let me show you an example of that one. Right, so I'll start with a video because it takes a bit of time. But essentially, at the outset, what it does is we have some instances that we want to make sure that they remain up to date. So the first thing that we are going to do is select the ones that we want to manage, and we will use Systems Manager to generate an inventory for us of what's the contents of those instances. I'm just going through that process as you see on screen, which is go to Systems Manager, select in this case just 2 instances, 2 web servers, and I say set up inventory, and you will see that right now it is in pending. And it will stay like that for about a couple of minutes. So let's jump out of the video. Let me jump out of this account as well. And yeah, because it's still thinking of the other account. And actually, let me jump out as well to another account. So where I finished there was that you have a series of data being gathered from those instances. The interesting thing is that when you use the inventory in Systems Manager, that is able to feed into config rules. Config is like a black box recorder on an airplane that records everything that is happening on your resources. In this case, it's also looking inside the instance and specifically at the inventory of its contents. So if I click on rules, you can ignore that error. If I click on rules, I should have stuck with the videos, right? If I click on rules one more time, let me, if I click, no, that's not the one I want. I'll add that. So if I log on again, 495.282, and SW, we are almost there, 5TH. One more attempt, and we move on to the next automation example, which is me going here. Boom! It wouldn't be a live demo if everything went according to plan, right? We're good there. Kinda. So our example, essentially, it's about the coordination between these 2 services, Systems Manager and its ability to gather inventory data, which in turn drives the config rules reporting on status, and we can still use Systems Manager, and I'll come back to that in a little bit, to actually perform some additional operations there. The examples don't stop there. You can also do things like look inside the instance, see if activities are happening that you don't recognize, and if you feel that the level of incident or the level of data that is being generated is something that triggers your suspicion, you can act on that. Let's give it a go on that one. So, in this case, let's say that I'm doing something simple as logging on to an instance over SSH. And our assumption here is that we don't expect this kind of activity to happen often, or at least if it were to happen, it would require some kind of process that should be authorized. So we are assuming that we are not authorized to do this stuff. So the fact that I just log on to an instance as a regular user, it is an event of interest. But it may not warrant me actually taking a direct intervention either to fix or to isolate or to do anything else. It means that I may want to be starting to generate some additional telemetry, but not necessarily more than that. Right? So if you see what happened in the second window where I have my email client, is that I started getting some information saying, hey, something or someone has logged on to the instance. So an event of interest, but it may or may not warrant additional action. If I switch on to root, which was the example that I was giving, right? I can still do something, but this escalation of events could dictate that in my world, I'm not willing to accept anymore. And what I want to do is actually to investigate a bit more by looking inside the instance, capture it for forensic examination, but remove it from use. If you see at the back, there's something saying, wait, identify the root escalation happening, and nothing to see, but you hear me clicking my keyboard and nothing moving, it isolates the instance, right? So the closed control mechanisms that we're talking about, they are not just things about at the platform level, they can be also inside the operating system and including in the network. And they could be even things like you don't want any public objects in S3, right? It happens. You have data that allows you to evaluate continuously if any action is being taken to expose those objects in some way. And you could take automated action to actually fix it. This pattern of S3 monitoring, something has come public, I automate the fix to make it private, is something that we have published. I'm not going to run, I'm going to leave that one as an exercise for you. So, but we have published the whole pattern and the whole code that goes with it. And, although we focus a lot right now, or I focus a lot right now until primarily on the platform, so AWS side of things, and a bit of the networking side, it needs to be full stack, right? Best practices are not just looking at what's happening on the AWS world, it's what's happening in all the resources at all levels, be it on the network, the operating system, and data protection. There is a session, SID206 on Thursday, just focus on the encryption side of things. On the OS security, I would just like to highlight, I showed you for a little bit, but it is quite an impressive product, the Systems Manager. So it is Secrets Vault, it allows you to act as a bastion node, it allows you to simplify so much the management of instances. The other cool thing that I really like about it is that you can use it on servers outside of AWS. And the other thing that I think is really, really good is that it is completely free. There's no charge for it. You pay for the EC2 instances that you run, but whatever you do with Systems Manager, it's free. I'd just like to highlight one more thing on my side, which is me talking or us talking about it. I hope it helps to inform you. Demoing, when it works, I think brings those ideas even better to life. But the most important thing is that you guys also, get your hands on and try it. We do run with customer security incident response simulations, which, as I said, practicing for when things go south and responding to them. And we also are running at reInvent something called the Security Jam, which is tomorrow from 8 a.m. And you guys are more than welcome to join. We provide all the infrastructure. You just need to bring a laptop, and you will run the demos that I did today. You will have opportunity to try them hands-on, firsthand. We provide everything except the laptop that you need to bring, but all the accounts and etc. But I think it's really, what is really helpful is, I'd like to thank once again William for joining us. Because if there's a customer that really pushes the boundaries and is continuously innovating on AWS and specifically on security, is definitely Netflix and operating at a scale that is quite impressive. So I'd like to welcome William on stage and show us a bit more.
Thank you. Awesome, thanks Armando. Wow, it's pretty impressive to see that with CloudFormation, you can not only take a file or a single line change in a file and deploy infrastructure, but you can also see if you have existing infrastructure in place, what is going to change. And this is important because as you make that code push at 4 p.m. on a Friday, you're going to understand if you have a weekend ahead of you or a weekend of work, right? It's going to tell you whether you're going to break a change, you're going to have to redeploy a server because of this CloudFormation change, and other various things depending on what you're doing. But organizations, SSM, CloudFormation are all powerful tools that you all should be using if you aren't. I'm Will Binkson, and I'm on the Security Tool Operations team at Netflix. And we're not like your traditional SecOps team in that we aren't just an incident response team. Yes, we'll respond to incidents in AWS, but that's our true focus. Our team is responsible for our AWS infrastructure security and ownership of our AWS accounts. So if a team needs a new AWS account, they come to us. And through that, we have identified 3 areas that we really focus in. Architecture, where we help teams securely architect solutions to their problems for their applications, be it cross-account, within the same account. If they need SNS, SQS, have questions on how to set those up, we help them out with that. Visibility, probably one of the most important pieces of the security operations team, is having the data and providing the visibility to see what is executing in your account. We have the CloudTrail, different types of events flowing from account to account. We need to be able to centralize that and view and have that visibility, not only for our team, but for the developers that are developing from day to day. And most importantly, once you have that visibility, auditing. Similar to what Armando said with config rules, having the data and being able to audit to make sure that you're within compliance, the changes that you've made are because of, say, an AWS auto-scaling event, something a developer did, but most importantly, making sure that it's not something that an outside person did. So making sure that those calls are actually executing within your account. Now, I mentioned we're not like a traditional security operations team. And you might think that we sit at a monitor all day like my friend behind me and stare at a monitor, waiting for those alerts to fire across and then respond. And you might think that given the scale and maturity of Netflix, that we have these pretty dashboards and a big room that we sit in all day and have fun, or maybe during breaks play Xbox. But in actuality, we have something even more powerful and simpler, and that's AWS. And there's 3 technologies I'd like to talk to you today about that enable us as a security operations team at Netflix to excel in our job. And those are CloudTrail, CloudWatch, and the service APIs. And at Netflix, we exclusively interact with the service APIs through the provided SDKs. We haven't written any of our own secret sauce. We use what AWS provides for us, and we use it to the best of our ability. And when I say CloudWatch here, I'm really talking about CloudWatch Events, and not necessarily the CloudWatch logs and metrics, although those are very important as well. The best way I could think of explaining technologies and how we use them for those that aren't familiar or as intimately familiar with the details behind these is through analogies. And so with CloudTrail, you can think of it as Big Brother, right? You have 24/7 recording of your operations and APIs that are being executed. Now, CloudTrail doesn't log everything. Like S3 data is not part of your standard CloudTrail. You need to enable S3 CloudTrail for that. SQS data calls, those aren't logged as well. But having that CloudTrail and understanding its limitations are something very important for you. The nicest thing about CloudTrail is not only do you have the 24/7 recording, is you can consider it as 24/7 recording with facial recognition, right? You know what roles are executing those calls, what user is executing those calls. Any cross-account assumption into a role, you see that assumption as well as any call after the fact. And we utilize that heavily for us to understand where the calls are actually being made from. Take a look at your CloudTrail data and understand what it looks like, what patterns are you seeing, and how can you use that to trigger alerts or whatnot. Every time an EC2 instance launches in your account, Amazon EC2 service is doing an assume role for you and creating a unique session that gives the instance ID in the CloudTrail data. That's very powerful, especially in an incident response situation where you're seeing anomalous activity, to know that this came from this instance and we should go quarantine it or take it down or whatever your playbook corresponds to. So in a sea of API calls, CloudTrail allows you to bring what you're looking for into a little more focus. So we have multiple accounts at Netflix. We centralize all CloudTrail to a single bucket in a security account, and we have our integrity file checks turned on to that to make sure that that data is not tampered with. And from there, we can do a magnitude of things, but some of the things we are attempting to do and working at are anomalous detection. we are flagging on any new call that we've never seen before in our accounts. So that minute that AWS releases a new fancy service at reInvent, the first time someone actually uses it after we've enabled it, we see that in our alerts. And we're also trying to take that same alerting to a specific role level as well. So trying to understand what's a normal API call for a role. What does it look like? What calls does it typically use on boot or throughout its lifetime? And if we ever see a role or an API call that we haven't seen before, maybe that's something we need to look into, because hopefully that server hasn't been compromised. And most importantly, one of the most important things that we've been doing with CloudTrail data is using it to actually right-size our IAM permissions. So at Netflix, we give developers a little more permissive role in the beginning to bootstrap them and get them ready. And we've got that dwindled down to what we think is appropriate. But as what we've found is, as applications are deployed, we see that some services don't use S3. Some services don't use SQS. So maybe we should pull those back. And so with CloudTrail, we're able to use that alongside Access Advisor to see what we should do on an IAM. And if you want to learn more about that, on Wednesday, there's a talk specifically on right-sizing your IAM role. Now, the next service is the service APIs. Very powerful, but I like to describe that as the census, right? You're trying to describe information about your account. So if you're in the United States, you're sending out a census hoping people fill out the data and send it back. Now, in the case of Amazon, you're going to get the result. You might not just have someone throw it in the trash. So maybe it's a little more like going door to door. And I say that because one thing to consider when you're choosing what technologies to use in order to monitor, as you grow, certain things might need to evolve, right? So if you consider going door to door, knocking, and asking your neighbor a question, what did you eat for Thanksgiving, right? It's very doable to go around your cul-de-sac or go around your neighborhood within a reasonable amount of time. But if you had to extend that scope to the city and go door to door, as one person, that might take you a really, really long time. And that's one thing that we've experienced as we've grown from a single account that's ballooned massively to multiple accounts, is that in order to describe everything fully, it can take a really, really long time. So I urge you to think about how you're using the service APIs. If you're using it to pull and monitor things, how long does it actually take? Is that acceptable for your risk profile, or should you make some changes on polling frequency or add other services on top of that as well? And that's what we'll talk about here in a little bit. And the last technology is CloudWatch Events, right? And I like to think it's like Twitter, minus the fake news, but it's real-time events, right? As people see things, they're tweeting it. And maybe it's more like push notifications, right? As things happen, you're getting a notification to your phone. The same thing with CloudWatch Events. As changes are happening in your account, be it Amazon making those changes, a user, an automated service, perhaps you've landed a CloudFormation template change into your Git, and then you have some CI process that's actually deploying it for you, you can see those change, right? It's like you're at a baseball game watching, and as the guy crosses home plate, your MLB app buzzes your phone in your leg. It's real-time event change, but it's important also to note that when you are having these events, AWS is providing you with just the information you need. This instance is going into the shutting down state. You've now scaled this autoscale group. Once you have that information, you get to combine that with the service APIs to understand what truly changed and do that difference for you. Now, if you're familiar with the Netflix culture, you already know that context is everything. And so before we get into the tooling that we've built and how it's evolved over time, I'd like to set just a little bit of context for you. So Netflix is big. We really are. We have a lot of infrastructure, a lot of accounts, and a lot of people working on it. We're so big that we have greater than 100,000 instances deployed in any given time. And that's just one account. Right? Our production account has over 100,000 instances deployed, including not at peak time. With those instances and the service we provide, we have greater than 1/3 of the US internet traffic at peak viewing time. Pretty impressive. We have thousands of changes that are happening in our environment daily to production. So if you think of Armando making change sets and deploying those, we have that happening thousands of times a day as developers are pushing new changes, tweaking the UI, adding new features, deploying a new A/B test. These things are changing and being pushed to production. And because of all these changes, we have greater than 1 million events per minute on CloudWatch. And if you're not familiar with the recent changes to CloudWatch Events, before, when you wanted to create a centralization of your CloudWatch event infrastructure, you had to deploy Lambdas to every region and every account, or create CloudWatch event rules that triggered SNS, which then subscribed to a queue in another account to try to centralize it. It became this orchestration nightmare, potentially, depending on what kind of tooling you had. But with the latest release of CloudWatch event buses, it enables you now to publish your CloudWatch events cross-account. So we can centralize all events from all our accounts into a single place. And it's very powerful, because no longer do we have to worry about orchestrating everything else. We can focus on the monitoring and looking at what the events are actually showing us. So I mentioned 1 million+ events. That's only in 2 of our accounts. So if you think about it, we run multiple accounts, and in just 2 of them, we have 1 million+ events that we have to process and determine what we should do. Is that something that was scheduled? Is it something we need to worry about? Did someone create an S3 bucket? If so, maybe we need to go make sure it's not public, right? That seems to be a systemic problem across many companies these days. And I mentioned we have multiple accounts. We do. We run multiple accounts. And as some companies are taking their multiple accounts and trying to consolidate and get a better handle on it, we're actually taking a step back and making a strategic approach to how we should actually segment our accounts, exactly like Armando said. We're using organizations to create accounts. It makes it really, really easy. Create accounts with your default role, and then from that role, you can actually orchestrate everything else, right? And with those accounts, we can actually segment permission sets. This account has these permissions, we're deploying these services. With organizations off, or with organizations on, excuse me, you can actually say, these kind of things can't run in this account. Lightsail cannot run in this account, or you can never peer a Lightsail VPC with our standard EC2 VPC, because we don't know what that's actually going to do, and we don't trust that, right? So when you're trying to operationalize and start your monitoring operation, it's important to know that there's a start, and there's a finish, but it's not necessarily a sprint. I like to think operations and the tooling we build at Netflix is more of like NASCAR. There's a kickoff, and it appears that there's like no apparent end because you're going round and around, but that's exactly what we do. As AWS releases new services, we take a step back and look at what we have deployed to understand, are we doing this the right way still? Should we make changes? I mentioned the centralization of CloudWatch Events. We never had that really before, but now we do with the event bus. So, it's NASCAR, and we're going around, we're redoing things, we're rehashing, and all throughout that process, we want to try to avoid a crash. But now getting into the tooling, I'd like to introduce, or once again, I'm sure you guys are all familiar with SecurityMonkey. If not, I urge you to just deploy it on the mere fact that it will monitor your S3 buckets and tell you if they're public. It's very important. But SecurityMonkey has evolved over time. Patrick Kelly from the security operations team at Netflix has done an outstanding job, along with others on the team, to build such a great tool. It monitors numerous technologies across numerous cloud platforms these days, but it's a great look to see at what history you have. You've made a change to a role, you can see what that change is. But it's important to know where we came from. And I mentioned as you grow in the service APIs, it's very important because when SecurityMonkey first was released, it had a single scheduler. in that every technology it supported ran on the same schedule. And if you take a look at our production account, in order to describe the roles completely, it can take up to 3 hours to describe all of our roles in production, including the policies and what managed policies are attached. It takes a really long time. So one of the first changes we made was we broke it out into schedulers per technology. So you can now say, okay, my roles need to be polled every hour, every 3 hours. I can do ELBs a lot faster because it's a lot quicker. Let's take a look at security groups on a quicker basis, because one small change could open us up to attack, right? And the way SecurityMonkey is actually written is it's very modular. If there's not a technology supported, you can write your own. If you have some proprietary rule you want to look for, write it yourself. There's watchers, alerters, and just recently we've been toying with enforcers, where if a developer creates a queue in an account that's open to the internet, or an SNS topic that's open to the internet, SecurityMonkey will detect that and automatically fix it. Our next target is S3 buckets. If the S3 bucket's created and it's public and it doesn't have a tag on it that says it should be public, let's just go ahead and fix it for that developer. So a very powerful tool that's evolved over time and is continuing to evolving. Our next step is to get it event-driven as well. So tie it into real-time events through a tool that I'll be showing here in a second, and keep SecurityMonkey up to speed a little faster than it currently is. But a very powerful tool. I hope you all use it and use it effectively. The next tool is Audit. And it is a caching layer, you can say, on Bodo 3. And no, I didn't have a typo. It has 3 Ws. I'm not really sure why. It was named before I got there. But it's probably our only tool as well without a logo. But the way Audit works is it's a distributed Lambda architecture, in that you have a single Lambda poller and a list of API actions you want it to call across all of your accounts in all regions. So if you want to describe instances, you give it an EC2 describe instance action. If you want to describe security groups, you do the same. And it'll handle the actual orchestration and scheduling of polling those. But the nice thing about Audit is it's writing all the results in a JSON format the same way that Bodo would return it to you, except it's handling all the pagination it's for you. So if you think about describing all your ELBs or all your instances, you might have to make several API calls to paginate through and get everything. This is actually handling that for you. So if you wanted to get that data, you would just download that file and have an entire file with everything you wanted. And that's written to a versioned S3 bucket, so that you can see what has changed from day to day, hour to hour. You can go back and look at previous versions there as well. So if you were writing tooling or monitoring, you can actually just pull this data instead of actually hitting the API yourself. And those that might have a big deployment with a lot of services running utilizing the Amazon API, you might already have run into API throttling and rate limiting. It's real. And that's part of the reason we actually have started looking at segmenting accounts as well, is to make sure that you don't have a rogue tool or a script deplete your API and then degrade your services. And I mentioned it's a Lambda-based infrastructure. We utilize Lambda a lot. And I just want to quickly touch on our experience with Lambda as part of an operations and security at Netflix. One thing really important, if you deploy Lambda in a VPC and tie it to events, make sure you understand the event profile and how often that's going to invoke. Because if you're not careful, you will exhaust all your ENIs, and when it becomes time to scale for peak time, you might not have any IPs to actually hand out. So one thing to keep in mind. And then just quickly, our last tool is a tool called Historical. And it is 100% cloud event-driven architecture combined with a poller as backup. So as events are happening in our accounts, Historical is seeing those in all the regions. It's processing them, by describing what has changed, and then it's logging a historical reference so we can see what has changed. But most importantly, it's publishing this information for other tools to use as well. So if your tool needs to interface and know what security groups are attached or what security groups are available in a VPC, you can see that with historical. And one of the coolest things that we're doing at Netflix now is we're trying to open source from the beginning. So it was great that we come up with some tools and then we deliver them full featured. With historical, we're trying a new route in that it's open source already. You can go to our Netflix Skunkworks GitHub and find it. But we're rolling it out technology by technology. So it doesn't support all the technologies yet, but it will. And if you'd like to contribute, we welcome that as well. But historical is very event-driven with a poller to make sure that we're true in our results and that we didn't miss an event somehow. But it's been proven very powerful to us and is enabling us to do other things, like when an S3 bucket is created, we can then go off and do a bunch of other things as well. Set up access logging, make sure it's not internet accessible, make sure it's tagged properly, making sure that our owners of the S3 buckets are named. So if we have any questions on what data lives in that bucket, we can actually go see that. But it's been really well for us, working really well. And I urge you guys, the most important thing is to understand your environment. How big are you? Can I run with just describing, or do I need to tie events in? The true power is in a combination of services, as Armando was showing with SSM and config. One service by itself might not be enough, but when you combine all of them, CloudTrail, CloudWatch Events, service APIs, you can create a pretty powerful solution to enable you in your operations from day to day. With that, I'll hand it back to Armando.
Thank you so much, Will. Very good. We are just closing out. I think the most important thing or the call for action coming out of our presentation is really, now it's your turn, Go and experiment this thing, Tools like Security Monkey, if there was a security tools Hall of Fame with Nmap and Nessus, Security Monkey would be there by now as well. And experiment with those, with audit and historical. And also, the demos that I showed you, including the ones in which there was a bit of a glitch, all the code for that is published. So you guys can try it firsthand and girls can try it firsthand. And second is, as I mentioned, we had quite a bit of demand for the security jam where you get to try this thing hands-on. We added some extra seats. So do come and join us. We start tomorrow at 8 a.m. and there's some cool swag to be won. Enjoy reInvent. Thank you so much. We'll be outside if you have any questions. Thank you. Cheers.